So we ended with this slide last lecture. And I said that one of the things here is that Mercury and Earth have practically the same density. So what does that mean? Well, like I said, it's almost the same density. Earth is only a tiny bit denser than Mercury. Now, that actually turns out to be very important because this is what we call the uncompressed or the compressed density. Turns out that Earth's gravity is actually squeezing it, making it even more dense in the middle than it otherwise would be. Mercury is smaller and has a lot less gravity. So that means if you figure out the uncompressed density, Earth is not quite as dense. I mean, so it's the core squeezed even more than you'd expect it to be. Mercury's uncompressed density is really, not that much less because there's much less gravity on Earth, or Mercury rather, than there is on Earth. And so because it is smaller. Therefore, that tells us the interior of Mercury is much, much, much denser than the interior of Earth. So that tells us the core of Mercury is a much larger percentage of Mercury than is the core of Earth. So I'll get back to that in a little bit. To really understand Mercury, Mariner 10 was launched in the 1970s using 1960s technology. And so it's no great surprise that we want to do better than that. So NASA eventually launched the MESSENGER spacecraft. It's an acronym for Mercury Surface Space Environment, Geochemistry, and Ranging. So the MESSENGER spacecraft was launched again in 2004 to Venus. So this is, like 30-something years after Mariner 10. So obviously technology really advanced in that 30-something years. Aimed at Venus, gravity tossed it. Actually, the first orbit was out, and then it came back towards Earth. Earth tossed it in towards Venus. Did Venus toss into orbit that didn't quite go near anything other than Venus again, and then that finally tossed it towards Mercury, and each time it went by Mercury, that the gravity of Mercury changed the orbit a little bit until finally in 2011, about 6.5 years after launch, then it went into orbit around Mercury and then continued to orbit Mercury for some years. And so MESSENGER was able to actually image 98% of the planet. So this was vastly more of the planet that we'd seen before, and carried a wide range of instruments that Mariner 10 didn't have. Well, duh, it's 30-something years later technology. As it orbited, then by measuring small changes in the orbit, that told them something about the interior of Mercury, the density of different parts of Mercury's interior. Again, this is very similar to what the Apollo missions did studying the moon. The mission was extended a little bit further, and then they extended a little bit further than that, but eventually they couldn't keep going forever. Budgetary constraints. So comparing Mercury to Earth. Again, this is a graphic right here that I updated a little bit. Earth is about 55%. Earth's core is about 55% of the diameter of the planet, and about 17% of the volume. Mercury actually, this was the first measurements here that are given right there, but then more recently they updated it to indicate that the core extends 85% of the way out and is 61% of the volume. Now, what does that mean? Well, it means that Mercury is basically like a big iron cannonball with a little small mantle of stuff around it. So Mercury is mostly core. In fact, Mercury is almost all core, and only a little bit of Mercury is actually mantle. And so that makes Mercury quite different. Okay. The original numbers here that are on this graphic are match what your book has, but NASA more recently has released new data right there. Mercury has a thicker crust than Earth does. Mercury's crust might be 100 kilometers thick. That's way thicker than Earth's crust. This is similar to the thickness of the moon's crust. It has a small mantle in there. In fact, nothing seems to have a crust quite as thin as Earth's. Earth has this incredibly thin crust. And again, this is one reason that we sort of suspect that a giant collision stripped off part of Earth's crust. So, Mercury. Okay, again, these are numbers straight out of your book right there. Again, this is indicative of the relationship between Mercury and Earth. Again, Mercury's core makes up a huge portion of the planet. Might make up as much as 2/3 of the mass of the planet. That's huge. Okay, that is a bigger percentage of core compared with any planet in the entire solar system. So there's no other planet in the solar system, no asteroid, no nothing that seems to have a planet that is that size. And so there's also indications here from looking at slight variations in the rotation of Mercury that something is moving around on the interior. This is conservation momentum, angular momentum. So that would suggest that the core is at least partially liquid. It's molten and stuff's moving around in there. This is a huge surprise because we did not expect this at all. Mercury is about the size of the moon. The moon has mostly solidified and cooled off on the interior. We expected the same with Mercury. Mercury has not done that, and so this was a huge surprise when they found that, because this was not at all what expected.